Chapter 1 is titled GIS Data. We use GIS data to represent the world around us. The world is made up of two types of data. Those that are discrete objects, which exist in one place and may or may not be present. Examples of discrete objects are roads, houses, state, and county boundaries. Continuous data exists over the entire map. It's always present and changes from one place to place. Elevation, temperature, and precipitation levels are examples of continuous data. Maps use different types of features to represent the world around us. Roads are best illustrated using line features, while ponds and forests are better shown using polygon features. Most maps are generalized, which means some data could be missing or slightly mispositioned. The amount of generalization is based on scale. Polygons on large-scale maps might appear as points or lines on intermediate and small-scale maps. There are two GIS data models, vector and raster data. The GIS software we use is capable of displaying and analyzing both data models. The bulk of GIS data that we use is vector model. Vector data is composed of points, lines, and polygons. The vector data model is best suited for storing discrete object data with precise locations, capable of storing several attributes, allowing multiple cartographic options, and is well suited for certain types of analysis, particularly those calculating area and links and connections. GIS is such a powerful tool because we're able to link important information to spatial features. Data such as population and population density is stored in the attribute table and directly linked to the features, or states in this case. Notice that Washington, Montana, and Idaho are highlighted on the map and their records are selected in the attribute table. A feature class is a collection of similar objects sharing the same attributes and type of geometry. Shown here are states represented with polygons, rivers represented with lines, and capitals shown as points. Coordinate systems are used to place the data somewhere on our planet. Every GIS data set uses X, Y, and some include a Z value to position the data. The choice of those X, Y, Z values is called the coordinate system. There are several different coordinate systems available, each having its own set of advantages. We'll talk more about coordinate systems in later chapters. Map scale is an important concept to understand while working with GIS. Scale is commonly given as a reference fraction. Here the scale is 1 to 100,000. The scale is unitless, which means that 1 centimeter on the map represents 100,000 centimeters on the real ground, or 1 inch on the map represents 100,000 inches on the ground. You can use the scale to calculate, make calculations. Consider this problem. Your map scale is 1 to 20,000 and you're planning a 10-kilometer run. How long should the route be on the map? The line on your map should be 50 centimeters long. When talking about maps, maps can be large scale, small scale, or intermediate scale. A large scale map has a small denominator such as 1 to 5,000. A small scale map has a large denominator such as 1 to 50 million. We are using ArcGIS Desktop, a product of ESRI. The software has evolved and so have the data models used in the system. Initially, coverages were the primary data source used with ArcInfo. Later, shapefiles were introduced with ArcView, and finally, geodatabases. All three data models are still out there and can be used with our GIS. Geodatabases have some major advantages and are constantly improving. However, I tend to still create a lot of shapefiles. There are three main components of ArcGIS Desktop. ArcCatalog, which you should consider as Windows Explorer for GIS. It's very convenient for previewing data, moving and copying files. ArcMap is used to compile multiple data sets into the maps for printing or further analysis. And ArcToolbox contains all the tools for further processing the GIS data. Like most software applications, functionality is limited by the price you pay. Advanced is the premium product with all the capabilities. Extensions are add-ins that are specialized sets of tools added to ArcToolbox. We will be using the Spatial Analyst extension later in this class. As mentioned earlier, spatial data can be stored in different file types. Using ArcCatalog, we can quickly identify these file types based on the color of their symbols. Coverages are yellow, shapefiles are green, geodatabases are gray. We can even identify the feature geometry based on the symbols within the colored icons. Those with 3 dots are points, those with 3 unconnected line segments or 3 line segments are lines, and those with 3 closed polygons are for storing polygon features. Be careful with shapefiles because there are actually several files required to make the shapefile perform in GIS. Notice how the building shapefile looks in Windows Explorer in the upper left corner. There are 7 files shown. It takes all 7 of those files to make the building shapefile perform correctly. In ArcCatalog, over to the right, only 1 building shapefile is shown. Always use ArcCatalog to move, copy, and manage your shapefiles. ArcCatalog will keep these required files together as you move or copy them. Coverages are also made up of several individual files. Coverages are no longer recommended for use with ArcGIS. Geodatabases are composed of a single file capable of storing multiple feature classes. Feature data sets within a geodatabase are used to group related feature classes. Here, the wildlife feature data set includes the antelope, bighorn sheep, bison, burrowing owls, prairie dogs, sheep, and vulture feature classes. There are 3 different types of geodatabases. The personal geodatabase uses the Microsoft Access data format. However, it's limited to size in 2 gigabytes. The file geodatabase is stored as multiple files in a geodatabase folder suitable for small work groups. The SDE database is designed for multiple users in large work groups. Geodatabases can store feature data sets, feature classes, tables, annotation, topology classes, network topology, which enables network features like those used by your utility suppliers to help locate problems within the system when they occur. It's important that you can recognize the different file types based on their symbols or their file extensions. One of the first things that we'll want to do is create connections to be able to quickly access our data. These connections are simply shortcuts that allow you to span networks quickly. Take care to connect to the top level of folders, and you should not connect to the same folder twice. It's a good idea to occasionally clean up your folder connections. With this information, you're now ready to complete the quiz for Chapter 1.